First process for wastewater treatment is the inlet works. The raw sewage is processed via a mechanical method where large materials greater than 5 mm, ranging from non-biodegradable solids to grit sand, passes through 3 types of screens: a mechanical fine band screen, manually raked coarse screen, and a conveyor with a screw wash press, following the vortex grit tank. Screening is the first unit of operation. This process removes objects such as rags, paper, plastics, and metals, to avoid any potential damage and clogging of the downstream equipment such as piping or appurtenances. The core screen involves a grill with approximately 5 mm or larger openings that capture and remove large solids, rags, and debris from the raw sewage. The vortex grit tank, as the name describes, removes fine grit by introducing air into the chamber along one side of the cylindrical tank, which causes a perpendicular spiral configuration to flow tangentially around the tank. Denser objects will eventually fall towards the center and be disposed of.
Maybe if I read a little farther I would know.
The Cleveland wastewater treatment plant contains one bioreactor plant that consists of an anaerobic reactor and an oxidation ditch, containing approximately 11 megaliters of wastewater, now consisting mainly of lightweight organic matter, grease or oil, nitrogen and phosphorus. The first step of this treatment process is the anaerobic reactor, or the primary sedimentation tank. The anoxic reactor mechanically mixes the wastewater in anoxic chambers to ensure low effluent nutrients and improve treatment efficiency. This process undergoes denitrification, a biological process by which excess nitrates are converted to nitrogen gas. The gas can be vented into the atmosphere rather than released into the waterways. In this reactor, the biological process of nitrification occurs, by which ammonia is converted into nitrites and then to nitrates. This biological process is beneficial as ammonia can impact various environmental and health factors, and where nitrates can be used for agricultural purposes due to the preferred chemical form for soil or water for plants. The remaining wastewater is broken down by bacteria that grow naturally in the biological reactor, removing organic matter, nitrogen, and phosphorus. In this process, the bacteria require oxygen to thrive, which is supplied by an aeration system. Internally, the system consists of 3 vertical shaft service aerators that violently stir air into the mixture, forming a foam-like substance on the surface called scum. Overall, the bioreactor system circulates around 20 to 15 days to ensure maximum reduction of raw sludge and removal of any organic matter. The primary settlement tanks are designed to reduce the velocity of the wastewater flow, allowing heavier organic solids called raw sludge to settle. This tank typically removes 30 to 40% of the total biological oxygen demand and 50 to 70% of the suspended solids from the raw sewage, and then moves on to the secondary zone called the anoxic reactor. Clarifiers are mechanically built settling tanks that run continuously for the removal of solids being deposited by sedimentation. Coagulation and flocculation reagents are added to cause finely suspended particles to clump together and form larger, denser particles called flocks that settle more rapidly and steadily. Generally used to remove solid or suspended particulates from the liquids for clarification and or thickening. Impurities that have aggregated, known as sludge, are discharged from the bottom of the tank, which is recirculated back into the system for additional removal, whereas the suspended particulates floating on the surface is known as scum. The separation of solids with pre-treatment solutions in the clarifier allows flocculation to occur more efficiently and readily, which benefits in the conservation of energy. The Cleveland wastewater plant contains 2 clarifiers which both run simultaneously. However, during maintenance periods or rare cases of operational failure, one clarifier can be shut down temporarily to perform repairs whilst the other clarifier can continue with its purpose, allowing the whole system to run efficiently without any delay. The squeeze-dry process removes liquids from 100% to 75% content in biosolids, which is recycled back into clarifiers, and the solids having the appearance of damp soil. The use of biosolids can be found in non-consumption agricultural facilities or landfill, as bacteria and solid wastes such as toilet paper are needed to be disposed of each day from the biological treatment plant. The digestion process is implemented. This method involves additional aeration as it minimizes potential odors from the biosolids during the squeeze-dry process, involving the compression of biosolids to remove as much liquid as possible. The process of disinfection involves a number of chemicals stored in separate septic tanks that treat effluent water differently, making it safe for potable water supplies and for healthy waterways. This plant uses 5 types of dosing agents. Magnesium hydroxide is an alkali that is recognized as a milk of magnesia for wastewater treatment. It has been widely used for heavy metal precipitation and acid neutralization of wastewater. Polymers are synthetic organic flocculants that are used for clarification, congealing, and dewatering purposes. Liquid alum functions as an exceptional primary coagulant and removes turbidity through a charge neutralization and flocculation. Zeolites have a predominantly high selectivity for ammonium and can reduce the amount of ammonium content in wastewater, as it has a detrimental consequence to the environment due to the toxicity and contribution to algal eutrophication and reduction in dissolved oxygen. Once the effluent water has been disinfected efficiently, the disposal of effluent is separated at 75% at Hilliard's Creek and 25% at Lagoon, which is then irrigated. Chlorination is the most common method for wastewater disinfection, as it is known to be efficient at destroying a variety of harmful microorganisms. It can be either used as an elemental chlorine gas or a chlorinated compound such as sodium hypochlorite solution. The disinfection of wastewater is the final stage of water treatment that delivers a certain degree of protection from pathogenic organisms such as cholera, hepatitis, or typhoid, along with a variety of bacterial, viral, or parasitic diseases.
Maybe if I prayed a little harder I would grow. Maybe if I read a little farther I would know.
From an aesthetic point of view, the wastewater treatment plants aren't the best accommodating or smelling places and often gives you with an unpleasant odor. Also handling very dangerous sewage that could affect the environment and nearby residences. The control room is essential as it simply overlooks the whole wastewater treatment facility by monitoring the measured values of each processor. In order to ensure that raw sewage inlets to wastewater treatment plants operate efficiently and safely, technologies are used to monitor wastewater routes at certain points. Monitoring elements such as odors, flow rates, and chemical dosing levels, among others controlling certain processes in case of emergency faults.